we look at some applications of partial derivative. And the first is the equation of a tangent plane and linear approximation. Okay, we first define the gradient vector. We call this function, or we call that, it's not a function though. We call this the gradient vector. Gradient vector is a vector. That's why it's not in a normal bracket, but it's in that bracket, right? Okay. Now, because it's a vector, it could also be written as del xi plus del yj plus del zk. Nice one. Okay, now gradient vector can also act on a function f, and that is going to be giving us fx, fy, fz. I just hope you understand the notation, right? It's the same as del f of x, del f, del f, del x, del f, del y, del f, del z, right? And it can also be written as fxi plus fyj plus fzk. These are vectors, so not naturally we put to show you vectors. Okay. Okay. A tangent plane. What is a tangent plane? A tangent plane is a plane that touches a surface at a point. So if you look at the dots, if there's a surface, I hope you can see there's some dot on the surface. Let's look at one dot as a point. So if a plane touches a surface at a point, we are going to call that plane a tangent plane. Now it's supposed to be flat, like very flat, but because the paper you can see is wobbling. Alright, so this is what we call a plane, and this is a surface. If a plane touches a surface at a point, we call it a tangent plane. So we look at how we find the equation of a tangent plane to a surface. Now, surfaces could be defined explicitly or implicitly. It's explicit if it is this, and implicit if it's that. First, we look at an explicit surface. The equation of a tangent plane to a surface is z is equal to f at, okay, let me do this right. The equation of a tangent plane to the surface z is equal to f of x, y at the point x naught, y naught is z is equal to the surface at x naught, y naught plus fx at x naught, y naught, x minus x naught plus fy at x naught, y naught multiplying y minus y naught. We'll first take a very quick example. I won't clean that, but let me clean the top, right? Let me clean the top. We call this equation the equation of a tangent plane, okay, to that surface. Let's take an example quickly. So if our surface, right, is z is equal to the lane of 2x plus y, we want to find the equation of a tangent plane to this surface at the point 1, 3. At the point 1, 3. Okay. Now, first we need to evaluate this function here at 1, 3. So I need f at 1, 3. Next, I need fx at 1, 3 and fy at 1, 3. Okay. From here, f of x, y is equal to ln 2z plus y. So f of 1, 3, when I put 1 and 3 inside that, I'm going to get the ln of x is 1, so I have 2 plus y is 3, so I get ln 5. That is the ln so the point is minus 1, eh? It's minus 1, 3. Okay, it's minus 1, 3, okay? So minus 1, 3. So here becomes minus. So here becomes 1. So the ln of 1 is 0. Right. Then next, I look for fx. When I differentiate f with respect to x, I get 2 over 2x plus y. I get this. I hope you can see. When I differentiate the length function, right, it becomes 1 over 2x plus y. And I'll differentiate 2x plus y with respect to x, and I'll get 2. And I have this, and multiply and I have that. Okay, so now fx at 1 minus 1, 3 is equal to 2 over 2 times minus 1 plus 3. And it will give me 2. Next, I find fy. And fy is going to be 1 over 2x plus y. If I differentiate the length function, I get 2x plus y, 1 over 2x plus y. And I'll differentiate what is inside with respect to y, and I'll get 1. It multiplies, I have that. So, fy at minus 1, 3 is 1 over 2 times minus 1 plus 3. And that is 1. And that is 1. So clearly, I can write my equation. I can write my equation. Okay, let me summarize all what I've done here. F at x naught, y naught, which is f at -1, 3, I have 0. Fx at x naught, y naught, which is fx at -1, 3, I have 2. And fy at x naught, y naught, which is fy at -1, 3, I had 1. So my equation of a tangent plane, which is z is equal to here f at x naught y naught, which is -1, 3. At -1, 3 give me 0. So this one here vanishes, right? Okay. Then fx at x naught y naught gave me 2. So I have 2 multiplying x minus x naught. Now what is x naught? X naught is -1. So I get +1 plus y, fy at x naught y naught gave me 1. So 1 multiplying y minus y naught is 3. So -3. So eventually z is equal to 2x plus 2 plus y minus 3, which reduces to z is equal to 2x plus y minus 1. This is the equation of the tangent plane to this surface at the point -1, 3. At the point -1, 3. Okay. It is as easy as that. Okay. There's another example in your handout, the one I sent you. So just look at it and you'll be fine. Now, if